Question number 6 has this pulley and string system, and they have explained everything here in this particular part. What is important here is to know that the string is 2.8 meter long. So 2.1 meter is here, that means this remaining part is 0.7 meters, and which means 2 minus 0.7, this is 1.3 meters above ground, this mass B. Okay, so now what are they asking us? They're asking us to find the acceleration of the particle and show that B has a velocity of 3.95 meter per second just before it hits the ground. Okay, so let's draw a free body diagram for the system. So the mass of B is 0.45 kgs. That means its weight is 4.5 Newton downwards. So this is the force which will drive this whole system downwards. But there is a frictional force, because they have written here the coefficient of friction is 0.3 between A and the surface. That is the force which will try to stop it. And what is that force? We know frictional force is mu times contact force, normal contact force. Okay, and normal contact force for this mass A will be 0.2 kg is the mass, so weight will be 2 newtons, and same will be the normal contact force, because there is no other force acting on this particular mass in vertical direction. So R is 2 Newton again. So F frictional force becomes 0.3 times R is 2 newtons, which comes out to be 0.6 newtons. So that means the resistance force is 0.6 Newton. Though they are not in same direction, but there is a pulley, smooth pulley without a friction. That means we can take these two forces against each other. So net force on the system is 4.5 newtons minus 0.6 newtons, which is 3.9 newtons. Now we have to find the acceleration of the system. So we know F net is m times A according to Newton's second law, and it is 3.9 newtons equal to mass. Now mass, because both the masses are moving, so we have to include both of them. So what are the masses? 0.2 and 0.45. Okay, and times acceleration. So what will be the acceleration? 3.9 divided by these two together will be 0.65, and that comes out to be 6 meters per second square. That is the acceleration. Now they are also asking us to show that the velocity, the speed with which it hits the ground is this 3.95. So we will use kinematic equation for this, which is v square minus u square equal to 2as. V square, final velocity we want to know with which it hits the floor, minus u, it was released. They have written here that particle A is released. That means the initial velocity is 0. Release means just let go, and it was stationary earlier. So it will be 2 times acceleration, we know now 6, and the distance B will move before hitting the ground. We already know this is 1.3 meters. That's the distance it has to move. So v square equal to 12 square, okay, 15.6, and if we square root both sides, v comes out to be 3.95 meters per second. That's what they asked us to show. Now let's talk about second part. They say given that B remains on floor. Now this particular mass B has reached the floor. That means this mass A will also reach somewhere here, same distance, it is 1.3 meters. So 1.3 meters it has traveled. So it is now 0.8 meters away from pulley. Yeah, and that's what they're saying. Find the speed with which A reaches the pulley. So this particular distance after this, what will be the speed of mass A? So we will use the same formula we use here, V square. We want to find out U square. We know that whatever was the speed of B when it reached floor, because they are connected with a string, same was the speed of A at this particular place. So that will become the U for object A, and that is 3.95 meter per second square, equal to 2 AS. 2 times A we don't know yet, but S we know is 0.8, isn't it? This distance is 0.8, which this object A has to travel to reach pulley. Now the problem is this A, we have to find this A. So let's do the same thing what we did for the previous one. In this case now only 0.6 Newton is the one which is stopping the mass A from moving. There is no 4.5 Newton now. So F net is 0.6 only, that is also negative, and equal to MA, M only, because B has reached floor, so B is not part of the motion now, only A is the one, so 0.2 is the mass of A. So F net equal to M times A. So A becomes minus 0.6 divided by 0.2, which is minus 3 meters per second square. So we will use that in place of this A. So V square minus 3.95 square equal to 2 times 3 times 0.8. And now let's move this 3.95 to the right side. V square equal to 3.95 square, and this was minus 3, sorry, this was minus 3, yeah, I did not write minus 3. So minus 6 times 0 minus 4.8, and V will be square root 3.95 square minus 4.8, and let's put this in calculator. It gives us 3.286. You can write 3.29 meters per second. That was the speed with which object A hit the pulley.